Hello everyone. Today we are going to discuss about the instruction cycle of a basic computer. Well, we are aware of high level language programming instructions, but we do not know how these instructions will be executing using the processor. Today we will see how step by step how the processor will execute the instructions. The von Neumann basic architecture is the input devices and processor will be divided into control unit and arithmetic and logic unit, and it will be connected with the main memory, and after that it will produce the output. But the instruction will be fetching from the memory, then how the instruction will be executed. This is called actually the execution cycle of a instruction. Let me show you. The control unit is basically divided into microprogrammed control unit, which will be conducted by the programming, and hardwired control unit, which will be controlled by the logic gates and hardware. Okay. So now we are basically talking about the hardwired control unit, how the instruction will be going to execute. The hardwired control unit will be consisting of the control unit will initiate the signals according to the digital clock pulses. These pulses will be, after generating these pulses, the arithmetic and logic unit will act according to the instructions of the control unit. But before going into that topic, we should know the basic terminology about the registers. Actually here I am talking about the basic memory size, actually that is 4096 into 16 bits length of a memory size, because we cannot show you the entire computer memory. Nowadays there is a large size of memory is available. We cannot show the entire memory structure here. That's why I am taking the small memory size, that is 4096 words total length, and the total word length is 16 bits. So here the basic registers are in computer we need if we want to execute any instruction. Program counter, instruction register, address register, input and output registers we need. So now we see the instruction here, the memory is containing the 4096 total length and 16 bits. For this basic computer, the instruction format will be divided into 16 bits format. 16 bits format, in that address is 12 bits format. Why 12 bits? 4096 is equal to 2 to the power of 12. So that's why 12 bits for the address and remaining 4 bits for the operation code. Here 4 bits for operation means 2 to the power of 4, 16 bits, that means 16 distinct operations we can perform. Suppose if you are having 6 bits, so that means 64 distinct operations we can perform. But here, so already we have know that instruction format is 16 bits length, and here 12 bits for the address and 4 bits for the operation code. See, basically the computer instructions are divided into 3 types: memory reference instructions, register reference instructions, and input output instructions. Here I have shown the entire formats of the instructions. See here, suppose 12 to 14 bits, if you are decoding using the decoder, that means from 0 to binary digit 6, those instructions are memory reference instructions. But in 6th instruction, 12 to 14 bits is only the integer 6, and the last bit is 1, that means it is indirect address. It shows the indirect address. Indirect address means it is register reference instruction. Okay, and last the instruction is entirely, if it is decoding the 7th integer bit and the last bit also 1, that means it is input output instructions. Okay, clear? So here I have explained the instruction types and the format of the instruction. How can we divide the format? Now let us see what is the instruction cycle phases. The first phase is fetching the address from the memory. Here I already shown you the memory is divided into 12 bits address and 16 bits data. Okay. The first program counter uses the first instruction address will be storing there. Here the first bit address is fetching by the program counter. After fetching the program counter, automatically the program counter will be incremented and it will be transferred to the address register. Here you have seen the entire figure. The address register is fetching the data from the program counter. After fetching this, the instruction register will get the data. Then it will execute the instruction, and by decoding the instruction using the decoder, so like this, last 12, 13, 14 bits operation code will be decoded by the decoder and the last bit will be transferred into the flip-flop and it will be executed. So see here how this will be, these are going to execute. This is the actually the phases of the instruction cycle. This will be ending the instruction cycle lecture.